Hello and welcome to episode 6 of Let's Code an Indie Game. This is the series where we go through the tools and techniques needed to get started with indie game development. In this episode we're going to look at adding rooms and a map to our game so our player can start to navigate the game world. But first let's recap what we did last time. So last time we added some vector mathematics to the game and we used it to move our slimes around. So let's take a look at our vector module and just remind ourselves what we did. We created a vector.distance function, and if you give this guy 2 positions, or girl, I must get better at that, gender neutral code. If you give the vector.distance function 2 positions, it will return the distance between those 2 positions. And you can also use the normalize method in our vector module, and what this does is it will give you back the unit vector between the 2 positions. And as we learned last time, the unit vector is important for when we want to make things move towards or away from each other. And we went ahead and we used the vector module inside of a new type of movement. And if we go into our AI movement and take a look at follow player, we can remind ourselves how it works. So we grab the player position and the entity position. We then get the distance between those 2 positions. And then if that distance is greater than 10, we go ahead and get the unit vector, and we use the unit vector to make the slime move towards the player. And the way we do that is we add the d, or the x component, the dx part of our unit vector, times the speed to the x position of our entity, and the dy part of our unit vector times the entity speed to the y position of our entity. And if we run the game, we can see that our slimes now follow the player around and eventually stack up on top of the player. Okay, so let's think about rooms. So we're going to do 2 things in this episode. One, we're going to create a class for managing and drawing our rooms. And 2, we're going to create a class called map, and we're going to use the map for looking after all of the rooms in the game, making sure that there's always a room we can move into and keeping track of which room the player is in. So let's go ahead and create the room first and make sure that works okay before we go on and wire up the map. So inside of Logic, let's create a new folder. Let's call it rooms. And inside of rooms, let's create a new file and let's call that room.lua. And as is familiar by now, I'm just going to wire up our module so that we can return something and hang some code off it. Because we want this to be a class, we're going to create a create method. Won't worry about arguments for now. And because we want to draw this, we're also going to create a draw method. And because we want our draw method to work on an instance of the class, we're going to make sure self is the first argument. And because we want instances, we should go ahead and create an empty instance to return for every time we call the create method. So we need a way of being able to tell which room we're in very simply. So for now, we're not going to get too complicated. We're just going to give each room a random color, and that's the color we're going to draw the room. So we'll be able to easily tell when we move between the rooms because the color will change. So inside of our create method, let's go ahead and attach a color to the instance. And to represent the color, we're just going to use a table with 3 values inside it. And those values will be math.random255, math.random255, and math.random255. And what this will do is it will give us 3 random numbers between 1 and 255. And the way Love2D handles colors is it expects 3 values, a red, a green, and a blue value. There's also a method involving 4 colors, but for now we're just worried about red, green, and blue. And by mixing those values together, it creates the color that gets drawn. So let's go ahead and use that inside of our draw function. And we do love.graphics.rectangle. Mode, let's go ahead and do a filled rectangle. Let's put x and y at 0 so it starts drawing in the top left, and let's pull out 2 variables for now. Room width is 800 and room height is 600. Now eventually we want to have our game window scale and we want to be able to deal with sizes dynamically, but for now we're just going to trust that when you start Love2D up, by default the window width is 800 and the height is 600. So let's go ahead and use those variables here. Okay, and now let's use our color. So love.graphics.setColor. And what we're going to do is we're going to pass in our color, but first we need to unpack it. So unpack is a function which will take the values from a table and unpack them so that you can use them as arguments to another function, which is exactly what we're going to do here. Okay, and because our room has a draw method and a create method, we should be able to go ahead and test it from inside of our main file. This isn't going to be where it lives eventually, but let's just make sure it works before we go ahead and write too much code, because the more code we have, the harder it is to debug what's going on. So source logic rooms.room. Let's pull in our room method, and let's just go ahead and in love.load we can, first of all let's make sure that it's local, so we'll just say test room. Then inside of love.load let's go ahead and do test room equals room.create, and that should be enough. And then inside of draw let's go ahead and make sure we do, and we're going to put it before our game.draw just so that it's the first thing that gets drawn. We'll go ahead and do test room draw. Okay, attempt to call method draw a nil value, so let's go back to our room, and yep, we haven't wired our draw method up to our instance, so let's just go ahead and do instance.draw equals draw. And now we can see that, well, two things have happened. One is the color has definitely changed, so we know our room is getting drawn, but also everything else in our game now looks kind of dark blue. It's got this dark blue tint to it. So let's go ahead and fix that. So if we look at our room.draw method, we set the color of the game, but we don't set the color back again. And what Love will do is if you set a color, it will draw everything using that color, including your sprites. It will try and sort of tint them to that color value. So there's a couple of ways we could fix that. We could just set the color back to being white, which would be 255, 255, 255, but a slightly nicer way of doing that is to make sure the first thing we call inside of our drawing method is love.graphics.push, and we're going to say push all. And the last thing we draw inside of our room drawing method is going to be love.graphics.pop. Now if we run our game, we see that the colors on our sprites are correct, but we also have the color of the room background as well. Now what's happening here is when we call push, we are basically resetting all of the transformations on the we're creating what's called a new graphics context. We're creating a new set of transformations to draw with, and when we call pop, we're resetting it back to where it was before. So this is sort of a way of separating your graphics calls so that your graphics code doesn't run into each other like it did then. I might do an episode later on how the graphics stack works, but for now we just need to know that if you use push and pop, it will keep your graphics code nice and separated. This will also be very important later on when we start using translations. Okay, so we have a room and we know that our room gets drawn. So let's go ahead and also create a map. And the job of our map is going to be to manage all of our rooms and also manage which room the player is in at any given time. So let's go ahead and create a new file in our rooms directory and call it map.lua. Let's do a local map equals empty table, return map. Because it's a class, we want to give it a create method. And we also want to make sure we have an instance of the map, which we can return. Okay, so a couple of things are going to go on inside of our map. The first thing we want to be able to do is to draw. So let's go ahead and create a draw method. Make sure we pass in self, because again it's going to be called on the instance of the map. And inside of our draw method we want to be able to draw, well, the room that we're in. So that means we need to keep track of which room we're in, and we also need to keep track of all of our rooms. So inside of our map.create, let's make sure we have a couple of variables which can do that. So we'll call the variable for keeping track of which room we're in, the room index, and we'll start with it equal to 1. And we'll also just make an empty table called rooms, which will hold all of the rooms that we have in the game. So if we go ahead and inside of our draw method do a self.rooms, and we use room index to pull out the index, or to pull out the room which we're actually in from our list of rooms, and then call draw on that, it should draw the room that we're in. So I'm not sure if we've used indexes quite like this before, but what you're able to do is if you have a table with a list of values in, you can get the value back out by just giving the index or the order of that value. So if we used 1, we would get if room index was 1, we would get the first room. If room index was 2, we would get the second room. 3, we would get the third room, etc., etc. So let's go ahead and swap out our room in our main method for our map. So we'll say local map is require source logic rooms map. Oops. And here we'll just call it, I don't know, the map, because we've already called the module map.create. And let's make sure that we draw our map inside of our main method as well, the map draw. Now what will happen is it will get upset with us, and let's just check that it's getting upset with us for the right reason. So if we go into map, so first of all we want to draw, wire up our draw method to our map. If we then try again, we'll see that on line 4 it says attempted to index a nil value. So what's going on here is it's looking for the first room in our game, but we haven't created any rooms inside of our map yet, so there isn't a room to draw. So let's go ahead and fix that by pulling in our rooms, or our room class. Using source.logic.rooms.room. And when we create a new map, we're also going to create the first room in our game, and we'll do that by doing a instant.rooms 1 equals room.create. So we're saying our first room is going to be the room we're creating now. Okay, if we make sure that's all saved and then run the game, see what happens. Map line 6, attempt to index a nil value. So let's take a look at that. We also need to do self.roomIndex, of course, not just room index. Okay, and now we're back to the state where we are drawing our room again. Very good. Okay, so we have one room, but that's not particularly interesting. We could have just drawn a rectangle. So let's go ahead and add the ability to create some more rooms. So on our map method, we are going to create a function called createRoom. And we don't actually need to take self here because this is just going to be a method we only call inside of our map module. So I'm going to go ahead and give it an underscore to start with to remind us that it is a private method. and we're just going to return room.create. So this will give us back a new room. We're also going to create a next room function, and this will be an instance method, so we need to pass in self, and a previous room function, and again we're going to make it an instance method. So let's think about what happens when next room gets called. What we want to do is create the next room in the game if it doesn't exist. If the room already exists, we just want to move the player into it. So we can start by saying if room index, or self.roomIndex, if this equals the number of rooms we have, and we can use the hash symbol here to count the number of entries in a table. So if we do hash self.rooms, we'll get back the number, which will be 1 at the start of the game. So we're saying if the room index is equal to the number of rooms, then we want to go ahead and do a table.insert. So this will add a new value into our rooms table if we do self.rooms, and then we can call create room, which starts with an underscore. So if we call next room and our room index is equal to the number of rooms, then we create a new room and we add it to our rooms table. Then all we need to do is say self.roomIndex equals self.roomIndex plus 1. So thinking about this for a second, if for whatever reason our room index is less than our number of rooms, what this function will do is it will just move us into the next room along. If room index is equal to the total number of rooms, then it will create a new room and move us into the next room along. So that seems sensible, seems like it should work. And for previous room, all we need to do is say if self.roomIndex is greater than 1, so if we have more than one room, then we want to say self.roomIndex equals self.roomIndex minus 1. So when we go to the previous room, if there is a previous room, and we know that because room index is bigger than 1, then we just want to move into that previous room. Okay, so where are we going to use these two functions? So we're going to call them from inside of the rooms themselves. So this means that our rooms are going to need an update method. So let's go ahead and, before we get any further, let's just wire these up. So we can say instance.nextRoom equals nextRoom, and instance.previousRoom equals previousRoom. And then inside of our room, we are going to create an update function. Say update equals function self, and also our update functions can now access the game as well. And for this update function, we also want to pass in the map. So when a room gets updated, it will be passed, it will be given the instance, so the room itself, the game state, and our map. And what this means is we can say if our game.player.x coordinate is greater than room width, then map next room. And we can also say if game.player.x is less than room width, less than 0. So this would be the player is all the way towards the left of the screen, and this is if the player is all the way towards the right of the screen. Then we want to say map previous room. And finally, we want to make sure, let's just wire up our update method. Update equals update. And let's go into our map. And the other thing we need to do is make sure that when we move rooms, we want to move our player as well. So let's make sure we have access to our game state. And let's make sure that when we move room, we put the player towards either the left or right, depending on if they moved into the next room or the previous room. So if the player moves into the next room, it means they've walked all the way off of the right of the screen, so we want to put them back onto the left of the screen. So we'll go ahead and do game.player.x equals, and we'll just say equals 1 here. And the same in previous room, if our player has walked all the way off of the left of the screen, then we want to put them over onto the right. So we can say game.player.x equals, and we can just say 799. Actually, I'm going to use less than 799 because we need to remember that our player has a width. So let's just say 700 instead, so we can make sure that we see our player and we don't draw them off of the screen. Okay, so our next job is to make sure that our map gets updated. To make sure that we always pass in game to these rooms, and to wire up our map to our game state so it can actually access our game state. So I'm going to go back into room and just make sure that when we call next room, we pass in game, and when we call previous room, we pass in game, because we need to access the player and that lives inside of the game object. And then we are going to go into our map and make sure that when map.update is called, just make sure it doesn't exist. Nope, it doesn't. So let's go ahead and do local update for map. Just want to make sure that every room, so just like we did with our game states for the entities, we are going to say for every room in ipairs self.rooms. Oh no, sorry, not for every room, of course not. What we actually want to do is get the current room, which is self.rooms self.room index, and we just need to call update. And we want to make sure that we pass in the game and the map, and map here will be self. So if we look at our room update method, we can see that it takes the room instance, which will always be self, but we also want the game and the map, so we just need to make sure those are passed through from our map update method, like so. And we know the only place we can get the game state from is from our game state class, so let's go into game state. Let's make sure that game state actually has a map. So we can just pull in our map module here. Local map equals require source logic rooms map. And then when we create a new game state, we want to make sure that we have a map. So the easiest way of doing that is to say instance.map equals map.create. And now finally, inside of our game state, we can make sure that we always update our room. So let's do that as well. Doing self.map update, and make sure that we pass in self, because self at this point is our game state. Okay, and finally, if we go into our main method, this is actually finally this time, we can get rid of our map module from here because we no longer use it. We no longer need to create our map here, and we no longer need to draw our maps separately. So we wrote quite a lot of code without running the game, so that makes me nervous that something is going to break, but let's have a look. Yep, game state line 10, attempt to call method update a nil value. So let's just check what's going on. In game state line 10, we call self map update. So and inside of map, we know we have an update method, but I have a feeling I've forgotten to wire it up, and yes I have. So let's go ahead and do inst.update equals update. Okay. So we don't see, or our background is black, which makes me think that our rooms are not being drawn, and I think that's because if we check out our game state, we also need to make sure our room does indeed get drawn. So again, we can do self.map draw inside of draw method in our game state, and now if we run the game, we should see that we have a room. And hopefully, if we go all the way to the right of the screen, we move in to our next room. And again, we move into another room, and if we go backwards, we can actually move backwards through our rooms. So purple room, slightly darker purple room, green room, and we can move back, slightly darker room, sort of lilac coloured room, beigey coloured room, and if we go all the way in this direction, nothing happens because it is our first room. Very cool. So one thing to notice is that currently our slimes don't follow us. They don't seem to change room, they just ignore the rooms completely, and that's something we're going to fix in the next episode. But one thing we're going to do now before we finish up is we are inside of our, let's do it inside of our map method. Inside of our draw function inside of our map, we're just going to go ahead and do a love.graphics.printf. Printf is for print formatted, where our text is going to be, let's go ahead and say room space ... self ... room index. And what this is going to do is it's going to join the string together. So 2 dots in Lua is how you join a string. So we're going to say room, add our room index, x and y, let's go with 350, because we know that we know our screen is 800 wide, so we know that half of our screen is 400, and we're going to take 50 off of 400 because we're going to set limit here to 100. Our y value, let's just set it to 20, so it's slightly down from the top, and align we're going to set to center. And the rest of our arguments we'll just ignore for now because we don't need them. Just neaten this up slightly. Go ahead and try that. And excellent, now we see in the middle of the screen we can keep track of which room we're actually in, which is just useful for debugging purposes. In the final version of our game we'll probably turn it off, but for now it's useful just to be able to write something onto the screen and see where we are. Excellent! Thanks very much for watching. I hope you're enjoying the series. As always, likes, subscriptions very much appreciated, and if you'd like to get in touch, ask any questions or give me any feedback to make this series more relevant or more useful for you, then please do so. Thank you very much, and goodbye.